So trigonometry exercise 6.2, question number 1. Find the angle of elevation of the top of a tower from a point on the ground which is 30 meter away from the foot of a tower of height 10 root 3 meter. First, let's depict this in the diagram. They're asking about the angle of elevation. Angle of elevation means, you just imagine you are standing in the ground and you are looking at the top of a pole or a top of a tower or something. Okay, so that's your angle of elevation. So here angle of the elevation of a top of a tower from the point on the ground. So assume you are standing here. The tower is here. You are looking at the top of a tower from here. So you are getting the angle of elevation over here. So we have to find out this alpha now. And they said it is 30 meter away from the foot of a tower. From the foot of a tower, you are standing 30 meter away. And the height of the tower is 10 root 3 meter. The total height of the tower is 10 root 3 meter. So now we are going to find the value of alpha. So you can apply trigonometric ratio on this. They're using tan alpha over here. The tan alpha ratio is opposite side upon adjacent side. So let's mark the sides. Here you have angle. So the side whichever opposite to the angle is known as opposite side. So this side is going to be opposite side. And you'll be able to notice a 90 degree over here. Here it creates a right angle, isn't it? It's a right angle triangle. So the side whichever lies opposite to the right angle triangle is known as hypotenuse. So this side is going to be hypotenuse. Look at the bottom. The bottom is going to be the adjacent side. So let's substitute in the opposite side and adjacent side. Opposite side is 10 root 3 and adjacent side is 30. So if you simplify this, you will get the answer as root 3 upon 3. Simplify this further, you will get 1 upon root 3. So take alpha. Alpha is equal to tan inverse of 1 upon root 3. What is the value of 1 upon root 3?
30 degree.
It's 30 degree. Yes. Just a second. Just a second here. Question number 2. A road is flanked on either side by continuous rows of houses of height 4 root 13 meter with no space in between them. A pedestrian is standing on the median of the road facing a row house. The angle of elevation from the pedestrian to the top of the house is 30 degree. Find the width of the road. So they gave a diagram on this. So they're saying that you do have a continuous rows of houses and height is 4 root 3. So for this house, it is 4 root 3 meter and for this house also it is 4 root 3 meter. And they're saying there is no space between the houses. Okay. This diagram represents the either side of the houses. Okay. Imagine you're standing here. If you're looking at the top of the house, the angle of elevation will be 30 degree. Okay, they gave it in the question already. They're asking about the width of the road, which means they're asking about the distance between the opposite houses. I hope the diagram is clear.
Yeah.
So they're taking this distance as the width. And in case if you're standing at the midpoint, you can assume this is W by 2 and this is W by 2. Okay. So we have to find the width now. We need to find this one. So they're finding this with help of tan trigonometric ratio. We know the value of tan theta. If you apply tan theta on this, what is tan theta? Tan theta is opposite by adjacent, isn't it? Can you apply opposite by adjacent on this and tell me what you're getting? Did you solve the tan theta? Are you getting the same? Are you getting 4 root 3 upon W by 2? Are you getting the same?
Yeah.
Okay. So it's 4 root 3. If this side is 4 root 3, this side is also 4 root 3, isn't it? So here you have angle. So this side is going to be your opposite side. So opposite side is 4 upon root 3 and this is your adjacent side. So adjacent side will be in the denominator. So if you solve this, you will get 8 root 3 upon W, isn't it? Eight root 3 upon W is equal to 1 upon root 3. So what is W? You can do the cross multiplication. It's 8 root 3 into root 3. It will become 3. So W equal to 8 into 3, which is 24. To a man standing outside his house, The angles of elevation of the top and bottom of a window are 60° and 45° respectively. If the height of the man is 180 centimeter and if he is 5 meter away from the wall, what is the height of the window? So, to a man standing outside his house, the angle of elevation of the top of the bottom, elevation of the top and bottom of a window. So this is the window. Elevation, angle of elevation is 60° when he looks at the top of the window. An angle of elevation is 45° when he looks at the bottom of the window. So that is 45°. And what is this 500 centimeter? From where they have written this? Okay, if he is 5 meter away from the wall. So from the wall, he is standing 5 meter away. So 5 meter can be converted as 500 centimeter. What is the height of the window? From the bottom, from the ground to the bottom of the window is considered as the height of the, it's considered as the X. You can consider this as the height of the window. So again, they are taking the same tan theta ratio. What is tan theta? Tan theta is opposite by adjacent. So if you apply tan 60°, this is going to be your opposite side for tan 60. And what is this? This is height of the window and height of the wall, isn't it? So it's going to be h plus x. So h plus x is going to be the opposite. And what about the adjacent? Adjacent is the base this side, which is 500 centimeter. So we'll write 500 here. And what is tan 60°? Root 3. Root 3 is equal to h plus x upon 500. So from this, you'll be able to find the value of h plus x. H plus x is equal to 500 into root 3. Again, they are applying the tan theta for the 45°. For this triangle, again, they are applying the tan theta. So tan 45° is equal to opposite upon adjacent. So it's x upon 500. And what is tan 45? Tan 45 is 1. So 1 is equal to x upon 500. From that, we can say the value of x is 500. You need to find the value of h, isn't it? They are asking about the height of the window. They are asking only about this height. So for finding the height, you can say h is equal to 500 root 3 minus x. And we know the value of x. What is x? X is 500. So it's 500 root 3 minus 500 h. So h is equal to, take the 500 as common. It will be root 3 minus 1. And what is the value of root 3? It's 1.732 already given in the question. So it's 500 into 1.732 minus 1. So you just have to multiply 500 and 0.732. Just multiply this and check whether you are getting this answer or not.
I got 366.
You got 366. Yes. So they just converted in the form of meter. It's fine. You can write it in the form of centimeter also. It's not a big deal. Question number 4. A statue 1.6 meter tall stands on the top of a pedestal. From a point on the ground, the angle of elevation of the top of the statue is 60 degree. And from the same point, the angle of elevation of the top of the pedestal is 40 degree. Find the height of the pedestal. What is pedestal, Manasi?
The thing that the statue is kept on.
Stand, isn't it? I'll just show you the screen. Can you see it? This is pedestal. This is pedestal. Okay. A statue 1.6 meter tall stands on the top of the pedestal. So they're assuming this as a statue, okay, which is 1.6 meter height. From the point on the ground, the angle of elevation of the top of the statue is 60 degrees. So imagine you're standing here and you're looking at the top of the statue. So the angle of elevation is 60 degree. From the same point of the angle of elevation of the top of the pedestal is 40 degree. So top of the pedestal, meaning is you're looking at the bottom of the statue. Okay, so which means you're looking at this point, or else you can say the same. You're just looking at the top of the pedestal with angle of elevation 40 degree. I hope the diagram is clear. So now they're asking about the height of the pedestal. They're asking about this height. Okay. So again, we're going to use the tan trigonometric ratio here. So they're taking tan 60 degree first. So you'll be able to notice a right angle triangle here also. Can you try this? Please try tan 60 degree and tell me what you're getting. So this would be opposite and this would be adjacent.
I got 1.6 plus h by d is equal to root 3.
You got 1.6 plus p. Okay. Okay. So tan 60 degrees root 3 is it? So it's 1.6 p upon d equal to root 3. So let's keep it as equation 1. We have to do it for tan 40 degree as well, because here also you'll be able to see a triangle. Opposite side is p. This is opposite, isn't it? P is opposite. And you have adjacent side here. So it's p upon d. I guess they gave you the value of tan 40 degree in the question itself. Yeah, 0.8391. For this thing, they'll give you. For 40, 50, for this kind of value, they'll give you. They won't give you the value for 0, 30, 60, 90, 180 and all that. For these values, we need to by heart the table. They won't give you that. For this kind of angle, they'll give you. For tan 40, they'll give you, which is 0.8391. So from this, you can say P is equal to 0.8391 into D. Okay. So they are substituting this value. They are substituting the value of P here. So it will be 1.6 plus 0.8391 into D equal to what? Root 3 into D, isn't it? They gave you the value of root 3 also, which is 1.732. So it's 1.6 plus P equal to root 3 into D. Just substitute the value of P here. You will get the expression like this. So from this, you can simplify this. How can you simplify? Just take the 0.8391D to the other side. So you can say 1.6 is equal to 1.732D minus 0.8391D. Subtract them, you will get 0.8929D equal to 1.6. So D is equal to 1.6 upon 0.8929. So if you simplify this, you get the answer for the D, which means the distance of a statue from the foot to this to the person. So why do you need that? In our question, they are asking us to find the value of P. They're asking about the height of the statue, isn't it? What they're asking? Okay, they're asking about the height of the pedestal. They're asking about this. How can you find that? P is equal to 0.8391 into T. You know the value of D, we just found that, which is 1.79. So P is equal to 0.8391 into 1.79. Solve them, you will get the value of P. So they are getting 1.503. I hope it is clear. We'll move to the next question. A flagpole, h meters, is on the top of a hemispherical dome of radius v meters. So with ancient buildings, you'll be able to see the dome structures at the top of the building. So they just mentioned the hemispherical dome here. So over here, they kept the flagpole. A man standing 7 meters away from the dome. Assume he is standing at the point E, 7 meters away, which means the distance between the foot of the dome to a foot of the man is 7 meters. Seeing the top of the pole at an angle 45 degree. So top of the pole at 45 degree and moving 5 meters away from the dome. So moving 5 meters away from the dome. I think it should be 2 here. This would be 5. So from the dome, he has moved 5 meters and he is here now. He is at the point A now and he is looking at the top of the pole with the angle of elevation 45 degree. And seeing the bottom of the pole at an angle of 30 degree. Seeing the bottom of the pole at the angle of 30 degree. So here is the bottom of the pole. Is observing that at 30 degree. Now we are asking about the height of the pole. They are asking the AD and radius of the dome. They are asking about this. So the very first thing is to identify the existing triangles in the diagram. Okay. So they are taking the triangle ABC first. Where is B? I think diagram is wrong. Just a second, Manasi. Changes into B. They're taking this triangle, ABC triangle. So what is tan 45 degree? Tan 45 degree is opposite by adjacent. So this is going to be your opposite. And this will be the adjacent. I think there is a mistake in the diagram, Manasi. Manasi, can you please send me the question from the textbook? Can you send me the picture of it?
Okay.
Yeah. Let's mark this as B. So take triangle ABC, this triangle ABC. The BC is going to be the opposite side. This is going to be your opposite side. And what is BC? BC can be written as BD plus DC, isn't it? And they are assuming BD as the height of the pole. Okay. So BC is equal to H plus, and DC is the radius of the dome. So from that we can say BC is H plus R. So that is going to be your opposite side. Let's find the adjacent side. What is adjacent? Adjacent is the bottom. This A to C is adjacent side. So AC is equal to adjacent side, the triangle. And what is AC? From here to here, it is 7 meters. And what about this? What about this length? This is nothing but radius of the dome, isn't it? So can assume this as R. So AC can be written as 7 meter plus radius. Can you follow this, Manasi?
Yeah.
So they are substituting tan 45 degree as opposite side H plus R upon adjacent side. What is adjacent? It's 7 plus R. We wrote it as R plus 7. Anything is okay. And what is the value of tan 45 degree? It's 1. So 1 is equal to H plus R upon R plus 7. Can write it as R plus 7 equal to H plus R. Cancel out the R. H is equal to 7. So we found the height of the pole. They are taking the triangle ADC, EDC now. They are taking this triangle. Again, they are applying the tan theta ratio. So tan 30 degree is equal to opposite by adjacent. This is opposite. DC is opposite, isn't it? And what is DC? DC is radius. And adjacent is E to C. And what is EC? EC can be written as EA plus, let's name this as F or something. Like EAF plus FC. So EA is 5 meter and EAF is 7 meter and FC is nothing but radius of the dome, which is R. So EC is equal to 12 plus R. So tan 30 degree is equal to R upon 12 plus R. And what is tan 30? It's 1 upon root 3. So you can say it's 1 upon root 3 is equal to R upon 12 plus R. Can you follow this? So 1 upon root 3 is equal to R upon 12 plus R. So it's 12 plus R equal to root 3 into R. And you know the value of root 3, which is 1.732. Just substitute that. Okay, before that, take the R1 to left hand side. Okay, maybe you can write it as R minus root 3R equal to 12. That's R minus 1.732 into R equal to 12. Take the R as common, it's going to be 1 minus 1.732 equal to 12. So R into minus 0.732 equal to 12. So it's going to be radius is equal to 12 upon negative 0.732. Radius cannot be negative, so you can remove the negative sign. And R is equal to 16.39. Can you follow this? Can you follow this? Just a second, Manasi. I think the student has joined. Shrenik, can you please wait for 2 more minutes? Can you please lead the meeting, Shrenik? Hello.
Hello?
Yeah, Shrenik, can you please wait for 2 minutes? I'll just finish this class and come.
No problem, ma'am. No problem.
Okay.
You want me to go out?
Yeah.
Okay, ma'am.
Thank you. Question number 6. The top of a 15-meter high tower makes an angle of elevation 60 degree with the bottom of an electronic pole and the angle of elevation of 30 degree with the top of a pole. What is the height of the electric pole? So assume you are standing here. Top of a 15-meter high tower. So assume this as 15 meter. You're standing here and you're looking at the top of a tower with the elevation of 60 degree. Okay. And again, with the bottom of an electric at the angle of elevation 30 degree with the top of a pole. Wait a minute, I don't get it. Why they are confusing? The top of a 15 meter high tower makes an angle of elevation 60 degree. 60 degree is fine. With the bottom of an electric pole. Do you have diagram for this question, Manasi, in your textbook? Can you hear me?
Yeah.
Do you have diagram for this question in your textbook?
No.
Can you please send that?
No, I don't have actually any diagram.
No. I don't understand the diagram. Just a second. The top of a 15 meter. Yeah, now I get it. Now I get it. Let me redraw the diagram, Manasi. I got confused with the tower and the pole. Okay. Assume this as the tower. Okay, this is the tower with the height of 10 meter. Let's mark it as tower AB 15 meter. So it makes an angle of elevation 60 degree with the bottom of an electric pole. So you have to draw on another electric pole parallel to the tower. Okay, let me mark this. This AB is tower. So you have to draw a pole parallelly. So assume this as the electric pole. This is electric pole. Okay, now you will get it. So now you read the first statement. The top of a 15 meter high tower makes an angle of elevation 60 degree with the bottom of an electric pole. So from the top of the tower to the bottom of the electric pole, this is how you have to reach. Can you follow this now?
Yeah.
Okay. So if I connect the foot of the tower and the foot of the electric pole, here I'll mark that angle of elevation 60 degree. Okay. I hope the first statement is clear. We'll move to the next statement. Angle of elevation of 30 degree with the top of the pole. Angle of elevation of 30 degree with the top of the pole. which means from the same point they are saying. Okay, from the same point. Let me mark it in a different color. Top of the pole. What is top of the pole? This point is top of the pole, isn't it? So from the same point, from the same top of a tower to the top of a pole, it is 30 degree. So 30 degree means you have to connect the top of the electric pole to a tower. This is how we have to draw. So here it makes 30 degree. Can you follow this? See, you have to rewrite this as top of a tower makes an angle of 30 degree with the top of a pole. Do you understand this? For the purple one, I'm writing this. Do you understand this? The diagram is a bit tricky. If you're able to solve the diagram, then it's going to be very easy. So it's A, B. Let's mark this as CD. CD is an electric pole. Let's mark this midpoint as E. The point which connects the tower and the electric pole height is E. Okay. So now we are done with the diagram. This AB is 15 meter. We know that. But we are not sure about the AE and this BE. That we can find it in the future. What is the height of the electric pole? Means they are asking about the CD. Okay. They're asking about the CD. So let's find out that. Okay. So take the triangle. Take the triangle ACB. I mean ABC. Take this triangle now. Okay. And apply tan theta on this. You can say tan 60 degree is equal to opposite by adjacent. What is opposite? Opposite is AB and adjacent is BC. Right? And we know the value of tan 60 degree, which is √3. And what is AB? AB is tower, isn't it? 15 meter is the height of the tower. So you can substitute 15 as, AB as 15 and just write BC as BC itself. Okay. So BC is equal to 15 upon √3. So from that you'll be able to find the value of BC. Can you follow this, Manasi? This is going to be 15 upon √3. Can you follow?
Yes.
So let's take another triangle now. Let's take the triangle AED now. You can take this triangle now. Take this one now. Again, you apply tan theta. Tan 30 degrees is equal to opposite by adjacent. So it's going to be AE upon ED. Can we say BC is equal to ED, Manasi? Can we say these two lines are equal in length? So from that we can say tan 30 degrees 1 upon √3 equal to AE upon ED. What is ED? ED is 5 upon √3. So from that you'll be able to find the value of AE. So AE is nothing but 5. If you simplify this, we'll get 5. Do you understand this? So they're asking about the height of the electric pole. We can say CD is equal to EB. Okay. So from this we can say the length of CD and length of EB are equal. Okay. So how can you find the EB? EB is nothing but it's AB minus AE. What is AB? AB is 15 and AE is 5. So by subtracting 5 from 15, you'll be able to find the value of EB. Isn't it? So EB is equal to 10. And we know EB is equal to CD. So CD is 10. Understood, Manasi? That's it. That's all about this question. I mean, about this exercise. Do you have any doubt in this exercise? Okay. Shall we stop here then? Okay, Manasi, we'll wind up the session then. Manasi, I'm ending the meeting.